So this is going to be the second case, which is repeated factors. So let's say, for example, you ended up with something that looks like this. So you had a polynomial on the top, and let's say on the bottom, you ended up with like an x minus 3 cubed. I don't know. So basically what's going to happen is that you're going to take this x minus 3 and you're going to repeat it 3 different times. So you'll have a over the first one, but to the first power, then b to the second power of the x minus 3, and then c of x minus 3 to the third power. That's basically what you're going to do. So it's actually more terms and a little bit more work to do. You can also have factors that kind of look like this. So maybe you can have one that's linear, 2x minus 3, and then let's say plus 3, and then x minus 4 to the third. Let's make it to the squared. So basically the way that this is going to work is that you're going to have a over x plus 3. So that corresponds with the linear factor. Now we got to do it for the repeated factor. That means you're going to have 2 of them. So it's going to be b over x minus 4 to the first power, and then c over x minus 4 to the second power. If this was a third, then it would be d x minus 4 to the third power. If it was 4, we would just keep going. Okay. One of them to watch out for, you might sometimes get like x cubed, x minus 4, and then x plus 2 to the squared. Let's say you get something like that. This value right here, and this is where the most mistakes happen, this is still repeated because you can write this as x minus 0 to the third power. So that's still repeated. So what that means is that the partial fraction is going to be a over x, that's the first, b over x squared, then c over x cubed. So that satisfies this guy. But now we got to do the x minus 4. Luckily, there's only one of them, so it's going to be d over x minus 4. And now you have 2 of these, so it's going to be plus e x plus 2, and then a, b, c, d, e, f over x minus 2 squared. So notice that the more terms that you have on the bottom, the more lengthier this becomes. Now, obviously, I'm not going to give you something like this on the exam. It will be ridiculous. So what we're going to do is we're going to do a problem where it's kind of feasible, okay? Or it's you can do it. So let's try this example. So let's say we want to find the partial fraction decomposition of this one, x squared plus 1 over x minus 1 cubed. Okay. So let's start off by writing the partial fraction decomposition. So notice that you just have an x that's not repeated, so it's just going to be a over x. Then this guy is repeated, and it's repeated 3 different times. So it's going to be b over x minus 1, then plus c over x minus 1 squared, and then plus d over x minus 1 cubed. Okay. All right. So now here's where the tricky part begins. So I'm going to write this again. So remember, you want to have an x minus 1 cubed in there. So let's look at the first term, a over x. Well, this guy already has an x. It just needs 3 more of these. So I'm going to multiply both top and bottom for this guy by x minus 1 cubed. So it needs that guy. So I'm going to multiply that first one by that. For the second one, this b over x minus 1, what does it need? Well, first of all, it needs an extra x. So it needs an extra x. And how many x minus 1s do you need? You don't need 3 because you already have 1 there. So you need 2 more. You need x minus 1 squared. So this will be x minus 1 squared. Okay. And then you're going to have the next one, which is going to be c over x minus 1 squared. What that guy needs, you're going to need another x and then an extra x minus 1. Okay. And then finally, you just have this d over x minus 1 cubed. The only thing that we really need for this guy is just going to be an x. So x and x on both top and bottom. Okay, so a little bit more involved. So now you have x squared plus 1 over x minus 1 cubed. So now ideally, everything now has an x minus 1 cubed on the bottom. Now what's left over is going to be this x minus 1 cubed plus bx x minus 1 squared plus cx x minus 1 plus dx. Okay. All right, and now what I'm going to do, notice that the bottom parts don't really matter anymore. So those are kind of gone. So all I'm left with is just this x squared plus 1. I'm going to FOIL this out, and I'm going to tell you what the answer is. The answer for this foiling part is going to be x cubed minus 3x squared plus 3x minus 1. Then the second one is going to be an x cubed minus 2x squared plus x. Then you're going to have cx squared minus x, then plus dx. Okay, so just to save a little bit of time. So you're going to have now, we're going to FOIL everything out. You're going to get ax cubed minus 3ax squared plus 3ax minus a. And then this next one is going to be plus bx cubed minus 2bx squared plus bx. And then this last one plus cx squared minus cx and then plus dx. So here's where you want to start grouping stuff together. Okay, so you're going to have, let me write red. So I have an x cubed here. Do I have another x cubed? Yeah, I have this guy. So I'm going to group those guys, and I'm going to write it like this. I'm going to factor it at the same time. A, B, and then the cube. Now I'm going to look for the one that's purple. So the square terms. So that's going to be this guy. And then do I have another square term? Yeah, I have this guy. And I also have this guy. So I'm going to have this, so plus negative 3a minus 2b plus c. And this whole thing is x squared. Then I'm going to have my x's, which is going to be this guy. And then this guy. And then this guy. And then this guy. So what is that going to be? That's going to be 3a plus b minus c plus d x. And then finally, we're just going to have the last guy, which is going to be this lonely guy, minus a. Okay, so now is the fun part, because now we got to break everything up. So notice here that we can write it everything as a system of equations. So we have a plus b is x cubed. Notice that there's no x cubed, so this equals to 0. This guy, this negative 3a minus 2b plus c is going to be equal to 1, because there's a 1 right here. Then you have this 3a plus b minus c plus d. That one is going to be equal to 0 also. And then finally, you're just going to have a negative a, and that's just equal to just 1, because that's only a 1 there. Okay, so now that we have that, this is going to be really easy to solve now, because now that we have negative a equals 1, then we know that a is equal to 1. So we can plug it into the first equation. So 1, oops, what did I miss? Oh, negative 1. Okay, so it'll be negative 1 plus b equals 0, which tells me that b is equal to positive 1. All right, so now let's plug it into the second equation. So we have negative 3, a is equal to negative 1, b is equal to 1, c, I don't know what that is, so let's solve for it. So 3 minus 2 plus c equals 1. This gives me a 1. So c equals 0. So that means there's no c term. Okay, good. And now we're going to look at the last one. So to figure out what d is. Minus c plus d equals 0. So a equals negative 1. B is equal to 1. C is equal to 0. And then you have a d. So it's negative 3 plus 1 equal, plus d equals 0. This gives me negative 2 plus d equals 0, so d equals 2. So that means that my solution is actually going to be equal to, the first one was a minus 1, and then it had an x. The b had the x minus 1. Okay, so that was 1 over x minus 1. And then the c goes away, and then the d had the x minus 1 cubed. So this would be the partial fraction decomposition for that one. Okay. So it takes a while. This one took a little bit of a while, but I want you guys to be able to see the algebra and see what the process is. Okay. Now let's just do one last problem. We're not going to go ahead and solve it all the way through, but I do want to show you case 3. So case 3 is basically irreducible quadratic factors. Okay, so when we talk about that, what we're saying is that if you have this polynomial, let me just give you an example. Let's say you had an x minus 4, which is a linear factor, and then you had something that cannot be factored like this. Okay, so this linear factor stays the same, a over x minus 4. We've already done this. Now this guy, what you're going to do with it, you're going to write it on the bottom. You can't factor it unless it's with imaginaries. But on the top, instead of making it a constant, now it's going to be linear. So it'll be bx plus c. Okay, so that's what you're going to have, right? Which is really annoying, but it's really good. Okay, so all we want to do is find the partial fraction decomposition, but do not solve. Okay, so let's say you had 3x minus 4 divided by x cubed plus 6x. Okay, let's just say it's that. So let's start out by factoring it. So it'll be 3x minus 4 divided by, factor that out, x squared plus 6. So notice here that you can't factor out the x squared plus 6. So you have a linear factor. So you're gonna quadratic factor. So you'll have a over x. That's gonna satisfy that x. Add it to now a linear factor, bx plus c divided by x squared plus 6. And this will be the partial fraction decomposition. Obviously, you can solve for it. You can do that as a little exercise if you really want to. But you can see how long these problems can take. So this will be irreducible quadratic factors. These are actually really good problems. You will be expected to do these problems when you get to Calc 2, but just giving you guys a little bit of a taste of what to kind of watch out for. And also problems like this can get really time consuming, and there's a lot of content that we got to go through. So yeah,